Hello, welcome back everyone. This is problem number 12 from an AP Physics C Mechanics multiple choice test. Let's jump right in. So, problem 12. A sphere of mass m hangs from two strings that each make an angle of 30 degrees with the horizontal. What is the tension T in one of the strings? Answer A states mg over 6, B mg over 4, C mg over 2, D mg, and E 3 mg over 2. So what we're dealing with here is Newton's second law. Newton's no, Newton's second law, which states force equals mass times acceleration. This was originally written as acceleration is equal to force over mass. Either one works, they're the same thing. So in this equation, or in this situation, the tension T is the force that is acting on this sphere of mass M. So our force is tension here. So what we're going to want to do is start off to make a free body diagram. This is always the first step in a force problem. Anything that deals with force, you're going to want to find out what forces act on the object by writing them out in a free body diagram. So here's our mass in a free body diagram. So we have one force going this way, one force going this way, and they're equal, they're tension. But what we want to do is we're going to want to represent these in terms of the y direction. So that's why we have this 30 degrees. We're going to use sine 30 to find the vertical component of the tension. So to do that, the tension here is going to be just tension. Okay, let's write tension is equal to mass times acceleration, because tension is equal to force. And then our acceleration here is just going to be gravity. T equals mg. So for this situation, this is going to be represented. One tension is going to be mg sine 30 degrees, because that gives us the vertical component going this way of the tension. That's all we care about for now. So now the next step is to sum the forces. We're going to sum the forces in the y direction. So the forces that we have mg sine theta over here, mg sine theta, which is 30 degrees, and then we have another of these t's over here. So the tension is going to be 2 times mg sine theta. And force is equal to mass times acceleration, so equals ma. And that equals so now let's think about what we can set this equal to. It's going to help if we have a quantity. So force in this case is equal to 2 mg sine theta, at least in the y direction, is equal to mass times acceleration. And also, since this system is not accelerating, there is zero acceleration. This thing is this is at rest. It's going to be equal to 0. So now that we have this, oh, this is correct. Yeah. So the acceleration again here is going to be gravity. And now let's solve this part of the equation. We can take sine 30. Sine 30 is what? It's going to be 1/2. So 2 times mg times excuse me. This should not be mg. This should be t. My fault. Because the tension Yeah, I think I might have said the right thing, written the wrong thing. Tension here is what we're multiplying by sine 30 to figure out the vertical component of the tension. Whoa. That's all. So, yeah, what we should be saying, we're looking, this is T sine 30. That's the vertical component of the force. So now here, we have 2t sine 30, and sine 30 is 1/2. So 2 times 1/2 times t is equal to mg. 2 times 1/2 cancels out, so t is equal to mg. That is answer D. Thank you for watching. Let me know if you have any questions about this one. Again, this is dealing with Newton's second law. We make a free body diagram, we sum the forces, we write our equation out, and then we start to solve. So, thank you for watching. Check back in for problem number 13.